Good day, everyone. Again, I am Sarah Vera Amshudbir, and let's have a quick recap about my geometric model, which is BoomSun Prism. So my geometric model looks like this. Um, in front, we have labeled it as A, B, C, D, E, F, G, H, and at back, we have labeled it 1, 2, 3, 4, 5, 6, 7, 8. And for the from the previous videos, we have talked about the if the geometric or if the given statement or the given set is form a group and if it and what are the subgroups of this set. Now we will talk about the just we will determine whether the group is cyclic and the cyclic subgroups. But first let's define how can we verify if it is cyclic or not. So to tell if a group and subgroup is cyclic, it must be an abelian and it must have at least one generator. So for the first picture or for the first subgroup, we have here is the improper subgroup that has the set set Z, A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8. And let's see if it's if this is a cyclic or not. And as you can see here in the picture, let's check on its symmetrical or symmetry. There is no symmetry in this table, therefore, this is not, or the cyclic is, or the group is not cyclic because it is not abelian, meaning the group is not abelian since the elements are not symmetric from its diagonal. For instance, the elements that are highlighted in red are not symmetric. Therefore, even if we no longer compute for the generators, we can conclude that this group M, or group Z rather, and this improper subgroup is not a cyclic since it's not abelian. So for this first subgroup, it is not a cyclic. Let's see for the next subgroup. Now we have here is the proper subgroups with the elements A, B, C, D, Z sub 1, A, B, C, D, E, F, G, H. And as we can see here, there is no symmetry as well. Therefore, it is not abelian since the elements are not symmetric from its diagonal. Therefore, this subgroup is not a cyclic as well, even though we haven't found a generator yet. Now let's check to our next proper subgroups. We have here is Z sub 2 is equal to A and 1. And as we can see here, there is a symmetry here, or symmetry happened here. Therefore, it is abelian. And we have here at least one generator, wherein for 1, we have 1 and A. So since this subgroup is abelian and has generator, which is 1, therefore this is cyclic. And as you can see here, we have here Z sub 3 with the elements A and 2. And also, it is symmetrical, therefore it is abelian, and it has at least one generator, which is number 2, meaning this subgroup is also cyclic. Now, we have the same process, or they are similar to each other. Z sub 4 is equal to A and 3. And we also have here symmetry. Therefore, it is abelian. And the one generator we have here is 3. Therefore, this is cyclic. For the next one, we have A and 4. Another symmetry. So it is abelian and it has one generator which is 4. Therefore, this is cyclic as well. And this following or this next subgroups are also cyclic because they have the same properties with the first subgroups. And lastly, let's check if the trivial subgroup is cyclic or not. So since this is a billion, which wherein the elements are symmetric from its diagonal, obviously, and at least one generator, which is A, therefore, our trivial subgroup is cyclic as well. So that would be all for the cyclic, or to determine if our group or subgroups are cyclic. Thank you.